Hello everyone, I am Elif. With my friends Zeynep and Ayşe, we're gonna talk about gait analysis systems. At first, I want to ask you, what is gait analysis system? These systems are used to identify and treat disorders and abnormalities in walking. And of course, they are not just used in medical field. They are also used for sports, rehabilitation, training, and robotic research. Evaluations are made easily with the data obtained from this system. Abnormal gait can cause many disorders. These disorders can be back pain and muscle tension, and of course there are several reasons that cause abnormal gait. The paralysis, injury, or fractures of the patients are among the main factors affecting the gait. Before explaining gait analysis systems, let's examine how the correct gait should be. At first, gait analysis is the study of human locomotion. Below, you see a single gait cycle. The first is the heel strike phase. At this moment, the heel surface contact with the ground. The second is heel off phase. In this phase, the heel is being lifted off the ground. The third is the toe off phase. At this stage, the toes are still contact with the ground. Fourth phase is mid swing. In this case, the angle of the knee is maximal. Finally, as you can see, a one gait cycle is completed. A gait cycle starts with one foot touching the ground and ends with same foot touching the ground again. A single gait cycle consists of the stance and swing stages and consists of a total of 8 phases. 60% of the gait is in stance phase. The stance phase is the period when the foot is on the ground. The first photo shows the first phase, initial contact. As you can see, the heel is in contact with the ground. The second image shows the loading response. It shows that the foot is firmly on the ground. The third one shows the mid-stance phase. It involves the movement of the body on the foot. Let's continue. Fourth is terminal stance. After this phase, the heel of the foot begins to rise. Pre-swing is the second image. From this phase, the foot takes off. Let's continue with swing phase. In this phase, foot takes off and cycle is completed. It consists of 3 phases. The first photo is initial swing. The fingertip is in contact with the ground, and this phase continues until the knee reaches its maximum flexion. Second is mid-swing. There is no contact between the reference foot and the ground in this phase. Last one is terminal swing phase. It is last phase, and in order to create a new gait cycle, the first position is taken. The other most important issue is posture. As can be seen in the picture, the first 3 postures are wrong. The fourth one is right for a normal gait.
I'm Zeynep and I'm going to mention about gait parameters, how they are combined as different tests and technologies, sensors and systems behind gait analysis. Parameters measured during gait are mainly frequency of unexpected abnormalities such as number of falls, length, width, distance, speed, angle, force, and duration. Then in the table on the right, time 25-foot walk is a standardized quantitative evaluation instrument consisting of 3 parts. In this test, specialist measures the time it takes the subject to walk a distance of 7.5 meters in a straight line. TOMA makes it possible to accurately evaluate elderly persons' balance and gait disorders in everyday situations. However, the test requires a great deal of time with active participation of the subjects. Time to get up and go requires patients to get up from a sitting position, walk a short distance, turn around, walk back to the chair and sit down again. Gait Abnormality Rating Scale is a video-based analysis of 16 human gait characteristics. The Gait Abnormality Rating Scale includes 5 general categories, 4 categories for the lower limbs, and 7 for the trunk, head, and upper limbs. Extra-laboratory gait assessment method aims to evaluate gait in the home or community. The parameters studied include step length, speed, initial gait style, ability to turn around, turn hand while walking, and static balance. Low speed, short steps, difficulty turning the head, and lack of balance are significantly linked to unstable gait. The typical image processing systems is formed by several digital and analog cameras with lens can be used to gather gait-related information. Techniques such as threshold filtering, which converts images to black and white, the pixel count to calculate the number of light or dark pixels, or background segmentation, which simply removes the background of the image, are just some of the possible ways to gather data to measure gait variables. Within image processing methods, the one technique has become very important at the present time: depth measurement. It's also called range imaging. It's a collection of techniques used to calculate and obtain a map of distances from a viewpoint. This technique makes it possible to obtain important elements of the image with better and faster real-time processes. Stereoscopic vision method can be used to determine the depth of the points. This technique is based on creation of a model through the calculation of similar triangles between the optical sensor, the light emitter, and the object in view. Time-of-flight systems are based on cameras using signal modulation that measures distance based on the phase shift principle. There, the phase shift, which is proportional with the covered distance, is measured in parallel within each pixel. In the pictures, you can see how the sensors are positioned in the lower extremity, how time-of-flight measurements are made and principles of it, the muscles working in the gait phases, and a gait analysis with image processing using multi-camera. Now I will summarize the technologies used for gait analysis, their features, advantages, and disadvantages. Force use. Force sensors like force-sensitive resistors are arranged in the sole of the shoes in such a way that the distributed foot pressure can be measured. Force shoes can be used anywhere, provide distributed pressure measurement and GRF datasets, but it is effectless for bumpy or uneven surfaces. Sensors are electronic devices that measure and report an object's velocity, acceleration, orientation, and gravitational forces using a combination of accelerometers and gyroscopes, and sometimes magnetometers. It provides 3D analysis, no need for controlled environment, and patient can be actively observed. Another technique of human gait analysis is well known, where active or passive markers are attached with the point of the interest of the human body. These marker points are traced by optoelectronic systems that converts the emitted or reflected light signals from the markers into electrical signals. These electrical signals are used to construct models for gait analysis. For quicker movements, accuracy decreases because of the sampling rate. Motion capture cameras can be used for both 2D and 3D analysis of human gait. A single camera is commonly used to acquire data for 2D analysis. In this case, the camera is placed in the parallel with the subject plane of the motion of interest. For 3D analysis, more than one camera is needed with complex setup, as the observation should focus on all plane of the movements. The pressure mud and force plates also work similar with the force use logic, but the specific distance is used for gait and sensors may differ. EEG provides the observation of brain activity during gait. It's combined with the other technologies, and EMG allows us to analyze muscle activity in the gait phases. In magnetic systems, ferromagnetic markers are used. In the experimented area, the magnetic fields are generated with the magnetic system, are distorted by the markers, and the distortion points are sensed by 3D sensors to analyze the movement of the patterns, but it's not suitable to cope with the modern technologies for the gait analysis. In acoustic tracking systems, ultrasonic pulses and ultrasonic sensors are used to determine the position of the movements. Electrogoniometer is an electromechanical instrument to measure angles of the joint movements. For both systems, potentiometric and flexible, when leg moves, EGM converts the mechanical signals into electrical signals. The drawbacks of the systems are the angle movements can be measured only for the one plate, and accurate calibration is needed for the joint axis. Moreover, the instrument is uncomfortable to wear and much difficult to fit with the joint, having more than 1 degree of freedom, like hip joints or ankle joints. Medical imaging is used with hybrid technologies to make more accurate and different purposes analysis in computer environment by using the combination of more than one technique. And finally, infrared thermography is the process of creating visual images based on the surface temperatures. In the pictures, you can see variable sensor systems, a wireless EMG, EEG system, how the infrared thermography is converted to image, a force view, and a flexible goniometer looks like.
The primary applications of gait analysis is divided into three categories: clinical assessment, support applications, and gait research. First one, clinical observations and health diagnostics. The main focus of clinical assessment is to describe the way in which a person walks. The gait assessment techniques used in clinical assessment vary with the skills and facilities available in the clinic, the nature of clinical condition, and the purpose for which the assessment is conducted. The major point of observations are steps per minute, pain, stride properties, step behavior, swing characteristics, stance time, distance traveled, gait phases, GRF, arm movement, shoulder motions, trunk movement, pelvic movements, hip motions, knee motions, ankle motions, foot actions, base movements, joint angles, muscle force, momentum, and COP/COM profile. The reasons clinical assessment is performed for are to document a patient's condition, to diagnose of an abnormal gait, or to make clinical decision. Different types of gait analysis data may be needed for different aspects of the gait assessment. For example, information on foot timing may be useful to identify asymmetries and may indicate problems with balance and stability, whereas the kinematics of limb motion describe abnormal movements. Causes of any abnormal behavior of gait may be musculoskeletal etiologies, painful segments of lower limbs kinetic chain, neuromuscular diseases, and myopathic conditions. Some of the conditions benefiting from gait assessments are cerebral palsy, Parkinsonism, stroke, and lower limb amputation. Second one, gait analysis in sports applications. Gait analysis plays an important role for athletes to prevent injury, to improve performance, and to choose the right equipment. Gait analysis and monitoring strategies are applied in various games in estimating athlete energy expenditure, assessment of limb segment acceleration, monitoring multi-limb motion characteristics, learning and studying combat sports. In assessing performance of a bowler, arm swing movements are studied combining with biomechanical analysis, where wireless inertial sensor is utilized. By focusing on movement patterns with kinematic and kinetic parameters involved in 10-pin bowling game, scientists fulfill the requirements to identify backward-forward swing time, arm swing angular velocity, arm height both for backswing and point of release, and wrist angle movements. These identifications allow bowling coach to analyze player motions in bowling and to set a standard range of each parameter in improving the performance of a bowler as well as preventing injuries. A recent study aims to design and develop smart clothing with integrated research on textile materials, human biomechanics, sensor technologies, and sensor networks. The focus of the research is to monitor human health conditions, as well as to study motion parameters both in physiotherapy and sports. Third one, research, robotics, and rehabilitation. Rehabilitation training provides the opportunity to patients for recovering their limbs movement functions to the maximal degree and can live a better quality of life. Nowadays, robotic systems are widely in use as rehabilitative tools to train up the physical impairments. Robot-assisted locomotor or gait trainer is now being used in some of the neurorehabilitation clinics, showing most promising outputs in achieving the rehabilitation goals. Studies show that the non-ambulatory patients experience robot-assisted gait training after stroke and spinal cord injury demonstrate an improved functional ability in natural walking. Besides the melioration improved EMG signals, ability to bear more weights on foot, walking performance with more natural gaits, gaining the walking speed, reductions in spasticity, and improvements in cardiopulmonary efficiency are also demonstrated. Please fill in the blanks. Some of the areas in which gait analysis is applied are The answer is medicine, robotics, textile, sports, and security.
Next question is, which of the following is not a phase of the swing phase? A. Initial swing, B. Pre-swing, C. Mid-swing, D. Terminal swing. The answer is B. Third question, this may be the factors that cause abnormal gait. The answer is paralysis, injuries, and fractures.
Question 4 is, write the basic parameters measured during the gait. Answer is length, distance, width, velocity, angle, duration, force, momentum, and number of unexpected abnormalities. Question 5 is, explain how gait is monitored with optoelectronic systems. Answer is, active or passive markers are attached with the point of the interest of the human body. These marker points are traced by optoelectronic system that converts the emitted or reflected light signals from the marker into the electrical signal.